Yeah. All right, I think we're going to get started. This is the software updates for Internet of Things suite working group. Welcome. This is the Notewell. By now, you've probably seen this a few times. Please speak up if you have any questions about it. So this morning we have a couple of administrative tasks. At the moment we have one note taker, thank you Soren, and one Jabber scribe, thank you Tiro. We need one more note taker. Can we get a volunteer? Yes, Robin, thank you. So we'll be taking notes in Etherpad, so feel free to load that up. And the Etherpad link is right here on the slide and also on the agenda. Here's our agenda for this morning. Any agenda bashing? Okay. So I want to give a short status report on the current working group drafts. Both the suite architecture has been in working group last call. We've gotten a decent amount of feedback on that draft. The authors have posted an update, and I think Hannes has a few questions that he's going to be talking through today. The information model was updated after IETF 104. We believe that the draft is progressing fairly well. We'd like to have some conversation later about the next steps there. We've been running a call for working group adoption of the CBOR manifest serialization format, which we also hope to resolve at this meeting. Okay, so at IETF 104, we pulled the room. There was a lot of support for adopting that draft and no concerns. We also took that to the list. There was some additional support there and no concerns. So at this point, we feel that there's consensus for adopting that draft. So we'll ask the authors to post the next revision as a draft IETF suite manifest. So thank you. I think that's everything on our status report. Any questions? Yeah, he is. Yeah, we can close that. Oops. I think so. Ah. There you go. So we've done well on some of our milestones, but we have a few that are lagging a bit. The fact that we just adopted the serialization format will allow us to close that one milestone. And we believe that the other drafts will probably progress fairly quickly. So we're a little behind, but we should be able to catch up, I think, in the next meeting or two.
Only 15 months.
So that's it for our working group status. So I think the AD is walking to the mic.
So Roman Danilio, if you could just give me newer milestones, just as a target, I think that sends a message to folks perhaps looking from the outside about when things might be ready. That'd be helpful.
Happy to do that.
And I won't really hold anyone to them, of course.
So you want even earlier dates?
All right, so let's start through our drafts. Hannes, would you like to come up and talk about the architecture? Switch that.
Test. Okay. So the architecture document is very close to completion, but there's still one issue that arised because of the synchronization with the IDOD liaison we have received. Brenda and I went through that liaison text, the new one, so we received different versions, but the most recent one made some other changes, specifically to the status tracker, which I would like to point out, and would like to walk away with a decision on what I should be doing there to change the terminology to make everyone happy. And I tried to, there's a longer email from Brendan on the list, which goes into essentially a review of their document, which I don't think I would want to go into here, because many of the things he points out actually unrelated to what we do here, but it's more a consistency check on what they wrote themselves. So it's hopefully something that they will take into account when updating their document. But this one is worthwhile to discuss. So we had this notion of a status tracker, and I copied, or I must sort of summarized the definition from the IETF draft and also from the IDOD document. And for the IETF draft, it's a fairly simple definition, because the whole, so like the bigger picture is only touched on, because most of the things we work on are really the whole manifest and the distribution, or making sure that the update happens rather than the actual monitoring of that whole thing. So that's why the terminology for the status tracker and the IETF draft currently only talks about monitoring the firmware update process. And so it says, for example, this it's a server-side component in these drawings, in the diagrams, which basically retrieves information from the device and then sees on like where is the update. So for example, is the device still downloading the new firmware image, or is it updating it already, or what is it actually doing? That's what the document currently says, and it may be insufficient, because if you look on the other hand at the IDOD definition, it talks about, first of all, monitoring some of the properties of the device, like what device version is there, like certain attributes, what are the some of the software versions running there. Then it also gets the update, because there the difference starts already, because the status tracker is not just a component in the cloud. It's actually, and I have a few diagrams here to illustrate this, it's actually also a component in the device itself, or it may be cascaded throughout the architecture. So it's, you can see this easily here. So, and there's another diagram in the following slide. So you have the status tracker that runs here on the device itself, but then it talks to a network local status tracker, and that may be sort of instructed by a status tracker that is in the cloud. So, and then there may be another one it cooperates with, and so on. So it's a slightly different sort of architectural model, if you will, and that also explains why it talks about these additional components, like it receives the requests and then checks the need for the update, assuming when it's local, for example, it has information about what the device's software version is it running on, then it can obviously do that. Initiates the updates, and yeah, and I mentioned this already, the issue of the cascading sort of architecture of these status trackers. So clearly there's a big difference between the two, and it evolved over time. So previously it was a little simpler in the earlier version, and now it's what it is. And so
on the bottom of the previous slide, it said maybe inside of a status tracker. Is that a typo from inside of the device?
Right. Yeah, that I think that's a typo. So it's really in the device, like shown here. Yeah. So for example, you have this IoT device that comes with a status tracker as a separate component, and then there may be actually multiple firmware consumers on a single device. And so, for example, this could be a device with multiple MCUs, so each one would have those type of things. And then there's, but Brendan may have a different view on this. And then the status tracker. All of them have the status tracker here in the device itself. But let's have Brendan say something.
So we have Brendan in the queue. Go ahead,
Hi.
Brendan.
Yeah, so the line about the status tracker.
Brendan, sorry, you're really choppy.
We can't hear you. Okay. So hopefully Brendan can fix this issue. So I've been wondering what should be done to the document to make some alignment and to make sure that there's some meaningful content in the device. So what often happens is, and I believe the status tracker is essentially a different way of saying that there's a device management functionality. And what that typically does is you have normally you have a component somewhere, a server-side component that the devices talk to, because normally, like in many deployments, it's you have the devices sitting out there, but of course the server needs to know about those devices up front. So you can't just send firmware updates there when it doesn't even know that the devices are awake. They are waiting for software updates. It needs to know like what is this device running on, is specifically if it wants to target a specific software update. Tero.
So John Keith Moore. In my the architecture anticipated by the ITU is poor. One, as it does not adequately cover the variety of scenarios required by different IoT devices based on differences in device function, connectivity, available power, etc. IETF should not try to do too hard to align with it, other than avoid conflicting and confusing terminology. And then there's Brendan was saying that there was this status tracker may reside inside the status tracker, which was the same thing that was noted in the chair table.
Okay. Yeah. Yeah. Mm-hmm. Okay.
Hi, Hannes, Jim Reed. You talked about ITU-T a couple of slides back there. Can you give some clarification as to which parts of ITU are doing work in this area? Because I don't remember seeing any of the stuff showing up in Statute 20.
This relates to a liaison statement that was sent from SG17.
Okay, thanks.
Mm.
Jim Reed.
Mm-hmm. So, so continuing what.
So, Takeshi from NICT, thank you very much for the discussion.
Raise the microphone.
Takeshi from NICT, thank you very much for the discussion for the status tracker. I just read email from Brandon and also discussion today. Sorry for that. And I think the discussion in the email is very correct. I agree with the point. And the point you said today is IETF should not be focused, putting too much effort. I also agree on that. So we, ITUT, will be doing our effort to follow the problem you raised. So we try to capture the issue you raised, such as the implementation issue for the developer. So I hope you can try to check again for the next revision of the ITUT draft. We try to follow the issue you raised. Thank you.
Yeah.
So it's okay. That was Takeshi. Takeshi is the editor of the ITUT document and the liaison that came to us, and we appreciate him being here. And so what I heard was that he's fine with the IETF documenting what we should be, and then the IQ document may try to match what we're doing, because we want there to be common editors and common participants, and so that's why we like the fact that there's overlap in participation. So.
Yes, as an editor or as a liaison from ITUT, yeah, I will try to capture your issue and follow your intention. Thank you.
Yeah. So continuing with my elaboration on how this device management works. So, so once the device registers and the server knows that it's there, and the server may query status information about like what is the device running currently. So it figures out that there's an update. It knows what devices need to be updated, and of course it also knows their communication behavior, because it may not all of the devices will be always reachable. So it deals with this. And so this is a purely communication specific issue, but still quite important, because after all the updates have to go there. And then it the way how the updates are triggered also varies. It may be purely like triggered by the server once the software, the new software is there. The server could trigger it, the update, and that would happen. Or it could be a policy based, depending on, like if you think about cars, you don't just do the updates whenever the software is there, but obviously have to take certain other aspects into account and so on. And there may be some user consent that takes place, etc., for some of the devices, because their functionality may change. So it's a fairly complicated process after all. Many things, and what I'm trying to get to is how much of all of this should we really describe? Because it's not core to what we actually do. I think it's useful information to know how these systems work today, but we don't actually standardize and define the status tracker, sort of like the IoT device management protocol in this group. There are already those protocols. So so how much should we accommodate for that to give the reader enough, and you and the, whoever wants to look at that document, to give enough information without going off into the weeds on explaining things that are only sort of or rarely or less frequently relevant for what we're actually doing in the group itself. And so what I'm proposing is we describe some of the stuff that I have on this slide with nicer wording, and in the terminology section, so it's more than what we had previously. We take some of that into account, specifically this kind of nested aspect, because that's also how things are deployed today. Not so much the status tracker on the device, but for example, if you have device management functionality also in gateways today, like there are lots of edge computing devices, and so you have this sort of device talks to gateway, gateway talks to some server, and I think that's also good to capture what is actually being done today. But I wouldn't go further than that, and specifically having the status tracker on the device itself, specifically if we talk some really constrained devices, that's rather unlikely. And maybe if that's important, there should be a different term for that to avoid creating the confusion. So that's my proposal. That would be an update, and I could spin that fairly quickly and have a few of you review that if you are familiar with this type of work yourself. I think I would appreciate your feedback. You may have a different perspective on the current deployment situation in that space, and I believe that would get us then to the end of this document. I think there wasn't anything else that we really need to make, and I'm sure IETF last call, there would be other comments and so on, but.
Any comments on this proposal? So do you have a sense of what time frame you plan to make these updates?
I could write some text this week.
That would be awesome.
If someone of you could have a look at it to make sure that it's sound, I could do an update.
Yeah, so I'm just going to go back to one of the points that you made, since the normative part of what this working group does is the manifest, right? And so we don't want to be over prescriptive for anything that doesn't directly involve the manifest. So keep it as high level as possible. And so, for example, in your first quote, where you say what could or should be monitored on the device, it's really more of a could there, right? Because it's not normative.
Sure.
And if there's
Sure.
other types of status tracking that's unrelated to the suit manifest, we don't want to constrain that because that's out of scope here. This should set the context here.
Yeah.
So, yes, keep it as high level and as flexible as possible.
Okay.
Yeah, you just have to set enough context for people to understand why the suit manifest does what it does and how it fits into larger context. So.
Okay. Sounds perfect. Yeah. So I'm not aware of any other requests for changes. Is there anything that comes to your mind? Something that I have to do?
So the plan is that the working group last call that's out will be resolved by these comments. So if you haven't read it, do it now.
Yeah. Okay. Okay.
All right, thank you. So unfortunately, Brendan's having some audio issues. So Brendan, we'd like to have you jump in the queue and give a quick status update on the information model. I'm not sure if you've resolved your audio issues, but do you want to give it a try again? If so, jump in the queue. All right, Brendan, go ahead.
Are you able to hear me okay?
Yes.
Oh, good. Okay, so
Yes.
for the information model, it looks like there are a lot of changes, but in fact, most of it is clarity edits, adding some cross-references, and replacing numeric identifiers with named ones. I did add two more significant edits. Those are the result of a review by a security engineer in ARM. The result of that was a new threat that I hadn't considered before, which is extra code following the code covered by a digest. So this is what happens when the payload that's delivered to a device is larger than is specified in the manifest, and the digest doesn't cover the whole thing. And for whatever reason, that still gets written into the device. So the solution to this is to digest past the end of the firmware, cover the whole available space, and use that as the firmware digest. So I've added this as a recommended security requirement, not a required one. Then there was a new use case, the addition of delegation of authority, and a usability requirement associated with it, which was the ability to deliver a delegated signing key with the manifest. And that is all for edits.
Yeah, so Brendan, at this point in time, do you feel like there's more work to be done on this draft, or do you believe that it's ready for working group last call?
Barring any further comments from the participants, I don't think there's anything else to do.
Yes or a no?
Yeah, can you repeat that statement?
I said, barring any commentary, I think it's ready.
I'm hearing that he's thinking that it's ready.
Brendan, can you just type what you said into Jabber?
Maybe? Hold on.
We heard that. Yeah, so we'll following this meeting, we'll start working group last call on that draft. So up next we have Brendan back with the suit manifest. So we'll see how this goes. Go ahead, Brendan. Still in queue.
Okay. So next slide, please. So I just want to do a quick overview to set the stage of why we have a change to the manifest model from a descriptive one to a behavioral one. Are you guys getting anything I'm saying? No.
Yes. Until that last question.
Okay, wonderful. I'm sorry, guys. I'm traveling and I have a very poor network connection. Okay, so just to follow up on the reasons that we're changing from a descriptive model to a behavioral one. These are the reasons devices need to be updated. Next slide, please. IoT updates should be easy, but they don't end up being easy because of having many possible actors, a diversity of update models and memory models, multiple functional units, and multiple security concerns. How do you go?
Talk about some of the points that he gets his.
So Brendan, we're going to have Hannes go through the problem statement slides, at least while you work on your audio, and we'll try again in a few. Let us know when you're ready.
Yeah.
Yeah, come back in queue when you're ready.
Oops. Yeah, these audio problems sometimes happen. So as you've seen also from, like, we had written some of those scenarios in the architecture document, also elaborated on it in the information model document, you have a wide range of different IoT devices. And while sort of the basic scenario is very simple, where you have a single MCU, you have a single firmware image, and that gets installed there and everything is cool, that's not necessarily all the cases that we have to deal with. If you open up one of the IoT devices that you find around, like this camera, or you pick any of those, you will see that there are many different hardware architectures that chip manufacturers came up with that require different treatment. You may have multiple MCUs. And so Brent listed a couple of those here, where you have, for example, in more modern architectures, you have a split between the secure world and the normal world, and you have different codes. So you have, you may have a different stack offered by the OS and the underlying sort of the middleware, sort of the kernel and the middleware that is provided by one manufacturer, including, for example, the radio stack, and then the application provided by someone else. And you may actually want to update those independently. This execute in place is also a very common technique. In some other devices, specifically wireless LAN devices, you often have the case that, very much like in more powerful process architectures, you actually need to copy the code first into RAM before you execute it. This is not necessarily true in many other devices where you execute it straight from flash. So it's a very, very different models, and you need to take those into account during the update. The update model, there are also different practices on how you actually do the procedure. Where do you copy? So you have in many cases, you will have the firmware, one firmware image, and maybe most likely another one running already on the device itself, maybe internally on flash or on a separate sitting outside connected using some bus system in external flash. And then you need to figure out, like, how do I get the bootloader to switch to a new to the new version that I want to boot? Is it just telling it, okay, it's somewhere else, or do you actually have to swap the code as a consequence of that? And that's what Brendan tried to allude here. So you have to cover different cases, and depending on who you talk to, they have different models. And you've seen that discussion when we talked to the MCU folks who joined the list and also co-authored the architecture document, who are working on different hardware systems than, for example, we do. So they try to cover a wider system. So we have a couple of OS vendors who target a larger set of hardware architectures. And so taking those different architectures into account was obviously part of the work, as you know, if you have followed along. We also spent, specifically in the information model, we spent a lot of time on talking about the different roles and the different players in that ecosystem. And as the firmware updates gets propagated and get sent to the device, there are many different actors that may influence the decision on what gets installed. We had these cases of medical devices where you can't just, as a device manufacturer, push the update to the device, but you have to take into account that there's certification processes and regulatory regimes that dictate on what you can and cannot update and who needs to approve the updates. And so we had many of those actors listed in the information model document, and that also influenced the design. Of course, if you ignore all of this, if the solution would be much simpler, you just take a subset. And so we try to, in the specification, the manifest specification, we try to accommodate for the different use cases, even though you may not use some of the features in your specific deployment, or at least not at a given point in time. Right. I alluded to that already earlier. So many of the devices today, even though they are very simple, so some of you, so who has been playing around with Arduino, like the 8-bit microcontrollers? Who has? Yeah, a couple of you guys. So like those are really basic microcontrollers and very simplistic. It's very nice to work with, and the pin layout is so, they're so huge pins that you can even solder them. So they're very simplistic, but in many IoT devices, even we talk about constrained devices, obviously not the way how they look like. So if you open up one of those boxes or your smartwatch, you will notice that there are lots of different components that need to interact. And specifically, since we talk Internet of Things, there's a common practice in industry that if you have radio modules, a radio component like Bluetooth Low Energy, or you have 15.4 or cellular, that they actually reside on separate microcontrollers, because the company offering that support, they branch it out to different components. And so you have different microcontrollers you have to manage the updates for. So that's why we had these requirements to have have the manifest to carry multiple different firmware updates and to describe what goes where. Yeah. So, okay. I talked about those in the context of the roles already. Okay. So that was a summary of what we have been doing so far. I don't know if Brandon.
This is actually about the behavioral.
This is now. This was more generic sort of introduction. Why did we end up with all these different sort of what, as an outsider, if you come into the group and look at the document for the first time, you want to like, oh, we talk about constrained IoT devices. Why is this so complicated? And that's the reason where we ended up. We initially thought it would be simpler as well, but yeah. That's what led to this behavioral manifest, and specifically the discussions that happened end of last year, beginning of this year, with the focus on making the whole thing as lightweight as possible.
And in part, that was born out from some of the hackathon experience too.
Yeah, and of course the desire to make it very small. Yeah. Okay, is Brandon back on track?
Brendan, do you want to give it another try? so jump in the queue. Give you a... All right, so I think you're going to have to continue.
Okay. So he's going to continue?
No, I think he's not there.
Okay, that's not that. Okay,
in,
so we'll start. So we in the discussions around December when Dave's colleague from Microsoft jumped in and suggested a different alternative format because he had a very specific architecture in mind. We had this debate about, like, could we have different formats? Could we come up with different ways to make it really optimized for specific environments? Like the whole debate we had about, could we just encode the structure as like a C construct and just basically you just copy the memory more or less from the server side into the client because you know that there is a specific memory structure. It's like a C construct. Mm-hmm. And then at the end, we came up with the decision that we actually want to have one format. We don't want to have different formats for the different architectures. But obviously at the same time, we want to have a very simple parser. We want to make because why do we want to have the simple parser and it actually relates to the tracker I talked about before. Okay.
All right, Brendan, we'll give this another try. Please go ahead.
All right, can you hear me all right?
Yes.
Excellent. Okay, so the initial point here, I'm sorry, I didn't quite catch where Hannes left off, so that I'll just jump. Can't have a lot of similar formats. There needs to just be one. And
I think we're still getting a lot of clipping.
It was only one clip. Yeah.
All right, so I guess Hannes will have to continue.
Yeah, I will continue. So, so previously what I mentioned with the status tracker, so when the firmware update gets sent to the device, it's running in like the regular application and it gets the update, but then it needs to do some parsing there. So that level of functionality there, you have typically more sophisticated code to do the parsing, and we have maybe CBOR code, of course, on COSI code for other reasons already at that part of the application firmware. And that's great that needs to happen because you don't want someone to send you garbage and then you switch off the device and then go into a boot state. But you would then trigger the device to go into this other state where the bootloader has to decide what firmware it starts. And that sort of needs to be a somewhat simpler format because you don't want to have a huge amount of code in that bootloader as well. You want to keep the bootloader as simple as possible, but you still need to, for having some security or a lot of security, you want to go sort of like through this secure boot sequence. So you're essentially reusing the same format, or at least that's what, for example, the MCU guys are looking into. They just strip off some part of what was received over the wire previously and verified. You repurpose that for the use of secure boot, because ultimately the bootloader comes up, it has a key provisioned, and then needs to verify, for example, the digital signature of the image it's going to start. And that's what it does every time it starts. So that has to be a very simplistic code. That's sort of like, you want to have those simple parsers specifically at the bootloader side.
Go ahead, Brendan.
Okay, I'm hoping this is working now.
It is so
we'll
far.
See how it goes. All right. So from what I heard, Hannes was talking about simple parsers.
Yes.
Okay. So, yeah, from what he was saying, I agree. The simple to construct a simple parser, you need to have few unique structures and low nesting levels. And as Hannes was saying, simple parsers are very much needed in IoT devices that have very constrained sizes and in bootloaders. The next thing is that most update use cases use similar operations. These are things such as copying a bit of firmware from one place to another, whether that's remote or local, checking digests, checking status of or properties of different elements of the device, and other things such as telling other parts of the device to suspend or resume function. But most use cases use these same fundamental operations, just in varying orders and with varying endpoints. And finally, the possibly controversial point is that an update consumer doesn't actually care what their update is. They care what they should do with it. So your IoT device cares nothing about what the update is. It just needs to know how to install it. So that makes the suggestion that perhaps we should look at a sequence of update relevant commands. Now, this is a bit of a rehash of the argument that I made for behavioral updates with the version 4 manifest. Next slide, please. So the current structure lays out several parts. We've got external information. Now, this is information that's used by code outside of the manifest itself. So that outside of the manifest processor. So that involves the structure version so that the parser is able to determine whether or not it can use the manifest. Followed by the sequence number. Now that's used by other parts of the code to determine which manifest it should process. Next, we have common information, which includes dependencies, component identifiers, and something called the common sequence. If you've read through the draft, or if you remember IETF 104, where I talked about this, you may be familiar already with what the common sequence does, but essentially it runs before any other sequence. And what it does is sets up the environment so that common decisions can be made in one place, which reduces encoding size, and common variables such as component digests can be initialized in the same place, which again reduces encoding size. Next, we have the command sequences. Those are the 6 following sequences: the dependency resolution, payload fetching, installation, and then validation, loading, and run. Those happen in 2 different use cases. The first 3 happen during installation. The second 3 happen during secure boot type operations. And finally, we have either text or a text reference section. This goes back to the severable section concept that we've discussed previously. Next slide, please. So in terms of a summary of changes, oh good, I forgot to fill in the numbers. Summary of changes from 04. I've moved the common elements into a nested B string. This is an effort to reduce parsing complexity and improve consistency in the format. Now, what I mean by consistency in the format is that everything else in the manifest structure is wrapped in a B string, with the exception of the structure version and the sequence number. So wrapping the common section in a B string also makes the parser more consistent. For reducing parsing complexity, this is because the common section is referred back to by all of the other sequences. So having a single common mechanism to point back to it makes it simpler to implement the parser, since it only needs to hold one reference and it has a fixed size in which to parse, which makes the parser a bit cleaner to implement. So I've also changed the encoding of command sequences. Previously, command sequences consisted of a list of maps. Each map contained only one key value pair. After discussion with Karsten and Hank, I have concluded that the most sensible way to implement this is by a sequence of keys on even numbers and values on odd numbers. But I don't think it has to be that restrictive. I think it just has to be a key followed by a fixed number of arguments. And those can be encoded in a flat way. They don't have to be in maps. Next slide, please. I've changed handling of optional sequences. This was a very late addition, so I haven't had a chance to work up the examples for it. After some discussion with experts on language design, I have been convinced that we were missing an else. Previously, it was possible to set a number of sequences together that each tested an if-type case, but there was no way to define that there was an else type case either. What they suggested was that we pack together any number of conditional sequences, but have them wrapped in one list and have the stipulation that at least one of these sequences must pass. This allows us to have a try, else type structure. I've added support for encrypted manifests. The mechanism to do this was to put in new values and define them as mutually exclusive, sorry, not new values, new keys in the outer wrapper and define them as mutually exclusive with the existing key for the manifest. One of these is a cozy encrypt structure, which defines the encryption information for the manifest, and the second key is the manifest ciphertext. Following discussions with David Brown, I've also added a swap directive, which will allow swapping two images, but that will be handled in a completely application-specific way. As always with the manifest, it tells the device what to do, but not necessarily the specifics of how to do it. I've also moved to defining suit-specific digest identifiers in response to some discussions that I had following IETF 104. There was some mailing list discussion about the named identifiers draft, including some digests that absolutely should not be supported, such as ones truncated to 32 bits, but not supporting some digests that probably should be supported, such as the SHA-2 224 family. And finally, there were a fair number of editorial changes. Next slide, please. I think that's it. Is that it?
So, Brandon, this is Russ. I have a process-related question. The behavioral document that we had going into 104 hasn't been updated. Is it because these have merged?
Yes, it's because these have merged. That's right.
Good. Okay. So I think post-merge that this document should be standards tracked, not informational, which is what it currently says at the top.
Oh, is it marked as informational? Okay, I can see if I can fix that.
I think you can fix that when you also post it as draft IETF suits. Sorry, you can fix that when you post the draft IETF suit version.
Sounds good.
Does anyone have any questions or concerns? Wow. Of course. Because I am doing the presentation.
Just, just honest, I at the DEEP meeting, I suggested to do already upfront preparation for the next hackathons. And because this meeting was a little inconvenient for some of the folks, like Naida, Emmanuel, the Indria guys, and Brendan is not here and so on. But for the next one, we were wondering in DEEP whether there would be interest to actually do a sort of a tutorial, hands-on tutorial before the hackathon, because it would allow some of the newcomers to actually get up to speed on the hands-on part, so they can actually then benefit in the hackathon, because otherwise it gets a little tricky. But if I have to bring hardware along, I need to know up front. I can't just fill up my luggage with stuff. So it would be nice to know if there's interest in doing that, and then I bring the gear along.
So in interest of making sure you bring clean underwear, I think you should do that. But seriously, we have learned so much from the hackathons in the past. I think that if we could do one in Singapore, that'd be really good.
Yeah, and really that's a separate issue from what you just mentioned. I mean, we can do the training as well. If it's not convenient to do it before the hackathon, we might be able to take some side meeting time, or or an interim even, right? To do that training ahead of the next IETF. So that's something else that we should consider. And I think we're interested in thoughts on what folks would prefer.
Channeling Keith Moore. This all seems needlessly parallel to me. Update instruction particles seems fairly likely to be platform specific. I think that was related to the behavior stuff.
Okay, thank you.
Roman, Neelu, back on the thread of a hackathon, I would strongly encourage some prep where I've seen kind of groups get together and come up with a plan coming into the actual kind of Saturday, kind of Sunday activity. There's been phenomenal results, so strongly encourage virtual interim or whatever might help.
Dave Thaler, slightly different topic but related. Hannes triggered, so I'm actually at the mic as a TEEP chair. And wanted to give a short report out on the relationship between TEEP and the manifest format. So TEEP had an interim meeting in between 104 and 105, and Brendan gave a presentation presenting the SOUP manifest format to the TEEP working group, so the TEEP working group could make a decision as to whether they wanted to take a dependency on SOUP. Okay. The outcome of that is the TEEP working group got consensus that says the TEEP working group and the OTRP protocol will take a dependency on the SOUP manifest. Okay. And so part of the discussion had to do with SOUT is primarily chartered with having a manifest format for firmware updates. And TEEP's use case is not necessarily updating firmware, right? It's updating stuff that goes into a TEE, which includes firmware and non-firmware, okay? And so way back even in the BOF, we talked about, is this for software update or firmware update or what? And so Brendan explained that the manifest format was generic enough to not be constrained to firmware only, okay? Even though that's the primary outcome or the primary goal of SOUT, okay? So that was the basis of the discussion. And so the consensus was that the belief is the SOUP manifest format, even though it's designed for firmware, it's designed for all the constrained requirements that we have in SOUT, it is not limited to that, okay? And so the consensus was that TEEP was planning to use the SOUP manifest as long as it stayed generic, right? As long as it stayed such that it was not limited to use for firmware, which is the current case. And Brendan, as the author, was explaining, yes, you could use it for many different purposes, right? It's a generic format. It happens to meet all the requirements for IoT and firmware and so on, because SOUT does. But it also happens to meet the requirements that TEEP had too. And so the outcome is that currently TEEP is choosing in the OTRP v2 document that Hannes authored and presented in the TEEP working group earlier this week, that it would have a normative reference to the SOUP manifest format, even for purposes not just firmware per se. Okay, that is the current status. And so from the TEEP working group, we hope that the SOUP working group continues to along the same lines as it is doing, and that TEEP would be happy to use it. And so that was me just summarizing as chair what I think the consensus from the interim meeting and the meeting earlier this week, which we had yesterday, where Hannes presented how we might encapsulate the suit manifest in the OTRP protocol.
So Dave, this is Russ's chair. Does this bring along with it any input to the milestones that we're going to be producing in terms of making sure we are not blocking their progress?
The TEEP chairs had that discussion, and right now our belief is that the suit manifest will naturally precede the OTRP spec in the progress, meaning we think that the suit manifest is more nailed down than the OTRP discussion. So the answer is yes, but it's not something that we have any concerns about at this point. So
Okay, thank you.
Minpai, I also work on the TEEP, so I just first want to concur what Dave said. Second is the comments on the importance of a generic format, generic terminology. And for TEEP, we decided and want to leverage a suit, but for our terminology-wise, we have said we have a rich word, let's say normal application and dependent trust application. Right, so the suit do not mention much for firmware, only limited firmware. It should be general software. And then we have software, we have a trusted application in TEEP world. That's one. Second one is about dependency. We also want to leverage suit to address the case where I install application one, it depends on TA1, TA1 depends on TA2, TA3, and go further and further. That's a complex problem. And I decided to say, okay, we can leverage suit, maybe say whether it's in suit scope, how much that will handle that in a simple way, I would say. We may be able to address it, but I think it's a complex problem overall, no matter if it's a firmware or software or trust application, it is.
I think Brennan's responding to Ming, so let him go.
Brendan, go ahead.
Hi. So suit definitely responds to the dependency question, and suit addresses it in a way that doesn't require the same signer on each of the components that you install. It explicitly allows different signers for different components. What it also does in order to forcibly break the possibility of circular dependencies is that it relies on cryptographic digests of dependencies, which prevents you from ever constructing a circular dependency. Hopefully that answers
I think as Brendan is explaining that, as you were breaking up there, yes, the suit manifest does have a way of addressing the circular dependencies question, and Brendan was attempting to give some details that were started breaking up as to exactly how. But the TEEP working group is saying the TEEP working group will just rely on the suit working group solving that problem, and the TEEP working group will not try to solve the problem themselves. It's just taking a dependency on suit to do that.
That's right. So but I will help to review and say how well it's addressed the problem. But also for the broad audiences, I hope to review this is one for the important topic.
Yeah, we'll look forward to those reviews. Thank you.
So this is Dave Taylor's TEEP chair. There was an open question as to whether the suit manifest or some other working group has a mechanism for doing the following. So one of the topics in trust execution environment provisioning is you're not just provisioning the binary, you're provisioning, say, configuration of the binary, right? And so we call that, we in TEEP call that personalization data because it may be encrypted by the device-specific key, right? So that no other device can. I'm trying to configure this device and only this device, right? And so the suit manifest is capable of passing, files and things, and so that could be considered to be part of the suit manifest. The open issue has to do with trust anchor update. And so if you're going to update, say, the keys in a device, whatever you're using for your trust anchor, you're going to update the contents of your trust anchor store. Is that personalization data that you might manage with a file in a suit manifest, or is that something you'd use a different protocol or mechanism for? That is something the TEEP working group does not have a proposal. It is an open question, And advice from this group or other groups would be welcome in TEEP.
Again, so I just have to say, the trust anchor are considered a little different from configuration data. Because configuration data is less sensitive than trust anchor. We talk about the router list of router CS certificates, just like browser, right? The browser vendors control that. It will take it very seriously. Who will you trust? Then how much is that in a suit as a format? I consider more a dependency format or manifest file versus deliver a trust list. That's a different problem.
This one is, yeah, since Dave and Ming brought up the deep topic, I'm curious whether we should add another use case to the architecture document and sort of pointing to the deep work, to the deep architecture document, and talking a little bit about the sort of software, the trusted application, and also the personalization data along with it. So
yes, I think I concur, Hannes. Well, at the P side, we do on that differentiation, right? There's different entities. Then we can clearly explicitly say this part relies on a suit. This part may need a different approach. So, and the suit side, we'll see whether particular trust anchor as a general treat has a different problem. Do not put in scope of this, but you say this will rely on a suit to solve it. It's a definitely change your use case scope.
Yeah, I think it would be useful to have some further elaboration on the requirements and, you know, what is going to be handled where. Maybe we can take that discussion to the mailing list and then work it there for a while. Right. Yeah.
Thank you.
Thank you. Maybe a cross-posting between both groups.
Randy Turner with Landis & Gear. I had, it would be nice at some point to get a definition of the word simple, because I was just doing a rough back of the envelope calculation on what I needed to implement this. So there's a simple parser. It looks like I need a cozy implementation, a CBOR implementation, some hashing. Post any hackathon, it would be nice to have somebody maybe let us know what the size of what they did was, or if they were doing a sufficient or a substantial implementation, what this might end up looking like. Because we have, in my company, we have sensors with 4K of RAM and 8K of flash and things like that. So we don't have multiple MPUs, tons of peripherals and things that have separate code bases that would use this, because those systems are often running Linux sometimes. But be nice to know what simple means and what a minimal implementation might look like, code-wise, code size-wise.
I think Brendan might have an answer to that. Go ahead, Brendan.
Yeah, I fully agree with you. Getting the sizes down is one of the top priorities I've had. Even going back to IETF 103, if you were part of that, you may have seen Emmanuel ask me that specifically. So I've been working as hard as I can to get those sizes down. Now, when you say a CBOR implementation, you should know that it doesn't have to be one of the existing CBOR libraries. I've built a sort of toy example as a pull parser, and it took about 200 lines of C for the CBOR implementation and under 600 lines of C for the simple processor. Now, you're not going to get away from about 1.5K worth of hash for the SHA-256 implementation. That's really difficult to get away without. I'm guessing that in sensors that small, you don't have signatures. So you're probably using something like HMAC for signature verification. That doesn't add much code. So you're in a really tough spot to get firmware update in a device that size. But it might be able to fit. I would question whether you need something that's completely application specific in an 8K range. That falls below the class 1 device. It's going to be tough, but we'll try and get it down.
Just a follow up on from I think Benjamin Dam, Itron. The ask, I think, was if you're going to be putting this code into a bootloader, then there needs to be a limit on how big the bootloader is. So how big it is probably should be in the, what size are you targeting?
This one is, and that was part of the exercise as we worked at the hackathons, and then the work we did in between, specifically like the CWAR question. Brendan addressed that, but also the COSI part, because it's maybe worthwhile to know that for the COSI implementation, you don't need the entire specification or implementation of the specification. You pick only those features that you really need, because there's a lot of stuff in the COSI implementation. We open sourced one of those implementations, and Emmanuel did another one to look at. I wouldn't say that they are both production ready. And unfortunately, I'm not aware of any production ready open source implementation. But I just posted a mail to the list where we did a write up of what we found out back then on the code sizes and the RAM requirements, and that's this paper that provides that information. And of course, the biggest size or the biggest chunks in the implementation is actually the crypto, because we've so far mostly focused on asymmetric crypto, even though the COSI work also supports symmetric crypto. But if you use, let's say, state-of-the-art B256R1 type of elliptic curve cryptography, then you pay a certain price. And we used, in our case, the Mbed DLS implementation and looked at various other stacks, and you can see how the size differs, how the speed varies. So there are various trade-offs with the different implementations, and you may want to take a look at that, depending on what exactly your requirements are, how much time you have for the boot process and for the verification, et cetera, et cetera.
And how would folks access this paper?
So the way we published it was it's through IEEE, but it's published in a way that we paid more for during the publication process, so everyone can access it for free, because otherwise it gets a little annoying for everyone in the IETF.
Hi there, Benjamin Dam, again. I would caution against viewing the crypto libraries themselves as being bigger than the processing code, because the assumption is that the crypto is all being provided in software and therefore part of the code base. But we're seeing more often where we're just building the crypto into the hardware. So the SHA primitive is provided in the hardware. The EC primitive may be provided in the hardware. Okay, so you're shifting the price from software to hardware. But for us, we're willing to do that. Now, I'm not talking about sensors that are in the 5K code space range. Like, our sensors are a lot bigger than that. But we're still talking class 1 devices.
We'll go to Hannes and then Brendan.
Mm-hmm. Yeah, and it's great if you have these things in hardware, and of course that will reduce your other code size. But of course, it just means shuffling things around, because in reality, if it's, for example, it's just a separate microcontroller or a different feature, so you could as well have a larger microcontroller and pay the same price and just have it in software. So you're moving stuff around, but ultimately the functionality has to be somewhere.
Brendan, go ahead.
Hey, the last time that this argument came up, I went and did some research on exactly what devices are available with cryptographic accelerators. And I came to the conclusion that anything that has a cryptographic accelerator of any kind typically starts at 128K, at which point I'm not really worried about it.
Okay, thank you.
channeling Keith Moore. One concern I have is how many different things does the implementer have to know and understand in order to build an implementation that's appropriate for the product. Some things like hashes and signatures are unavailable, but encoding really needs to be as simple as possible. The manifest model needs to be as simple as possible. Encoding behavior strikes me as making things too complex for some use cases, etc. We should keep in mind that the implementer audience for this is much wider than for the typical IETF protocol.
Any comments on that? Brendan, go ahead.
Hi, Keith. I completely agree with you. It does need to be simple. I think that the behavior encoding will turn out to be simpler than you expect. The only way to prove that to you, of course, is to show you an implementation. So that's what I am working on. Now, the thing that we need to do is to provide a few example sets that show what you would need to implement on a few classes of device.
I think what I heard from Brendan was, he's providing one example, but that doesn't necessarily cover all classes of devices. Brendan, you were being a little choppy. If you have something else to say, could you please say it in Jabber?
This one is you want to let Brendan?
Okay, channeling Keith again. Could not hear all what he was saying, but I think the implementation is what needs to be demonstrated. If the specifications aren't clear, the example implementation won't solve that. So what he's saying, I don't think the implementation is what is needed to demonstrate it, because he says that even if you have a new implementation, it doesn't make that the actual specification is clear.
Don't go away, Brendan responded.
Okay, Brandon, I think it will turn out much simpler than you expect. We also need to provide a few example cases for different classes of devices.
And that also leads to the hackathon question. So if different people come along with their favorite devices, I think it gives us a better way to sort of get the size measurements down. And we had some of those guys there already with different devices, but having more people come along and participate so that we maybe at the end even have a reference implementation that people can use to avoid mistakes or basic mistakes would be really useful. So if you guys have a chance to participate, that would be cool.
That's how I opened my account.
We were
seeing, they can see what's
yeah. So I can post some. I can post.
So that's basically how I opened my comment. Is it'd be nice to
Your
see
name?
Randy Turner. If we could see some implementations post hackathon, or even the one that Brendan's working on, it'd be great.
Yeah, I can post the things that we had at the last hackathon, put them together. I think Emmanuel showed them on the slide, but from the last IETF meeting, but I'm not entirely sure whether he indeed included the links or just the links to the write-up.
So one thought. Well, let her repeat.
So I was just adding. So Roman Danilo again. I mean, we're talking about kind of implementations. We're talking about things that are in slides, things are a result of a hackathon. I might strongly encourage the creation of a wiki page that just enumerates said implementation. So we have a running list. Folks can see it. Folks can add to it in a transparent way. The track wiki, a GitHub wiki, whatever makes sense.
I was also thinking that we could write up some implementation considerations, and maybe as we get further along, an implementation report that would talk through, some of the work that has been done.
Roman did it again. That would be fabulous. when I read the Shepherd reports and I want to bring documents forward, one of the first things I check for is, do you have running code, or are you just saying the working group kind of talked about it? And I have a tendency to want to have a conversation about drafts that don't have a piece of running code that you can point to. And typically I like to see a URL as well. So all of this would help. And so I would appreciate that.
Yeah.
So thank you, great suggestion. We do have a suit wiki page created right now that only has like one main link in it. And I think it's a great suggestion. No, it doesn't have implementations on it yet, right? And so thank you for that suggestion. Let's go ahead and do that as chairs. If people have implementation links, send them to us. I don't know if other people have the option to edit the wiki themselves or if it's just the chairs. If you have a login, yeah. So we have a page to do that. You can get to it on the data tracker or the working group. You just go to the wiki link. Let's collect them there. Great suggestion. So chair, as chairs, please send us links or edit the wiki yourself, your preference.
And one particular practice I've seen very helpful as we kind of talk about this, whether you're watching TLS, DOTS, and ACE. This may not be the case in this working group, but as more documents get published, it's not a matter of just saying, I have an implementation for this working group. I have an implementation relative to a particular set of drafts and a particular set of versions of the draft. So if implementers can talk about it relative to drafts and specific version numbers, that would be a great help.
Any other comments on this or any other topic? So I think the next thing we have on the agenda is a quick wrap up. Now. So we had. So I believe I'll start and then my co-chairs can add to this. We talked today about updating our milestones. So we'll propose some new dates that are more reasonable to our AV. We talked about starting a working group last call on the information model, which we can do, I think, immediately following this meeting. I think that was what I recalled.
Yeah, I think we might want to give a little extra time just because of the travel back from this and the high vacation season, but I think we'll do that. Rev and a confirmation.
Right.
Yeah, Roman, I'll repeat my point about kind of milestones. I know we've had broad IETF-wide conversations about how real they are, how are they not. I think the most important thing for the publishing the milestones is about getting other people involved in the work. And so folks from the outside who are perhaps not in the room can actually get a better sense of the timeline of when things might be ready. And so it's actually, I view it as important as a project management thing lightly, but as a marketing tool a lot more.
Right, so we can do maybe a 3 or 4 week, last call on the information model to allow for time for vacations and whatnot. And then the other action I think was since we've completed the last call on the architecture, in order to complete the last call on the architecture, we need to do one more rev to adjust the text around status trackers. We'll be looking for that by the end of this week. And then we'll work on red. Yeah. Yeah, then we'll write up the Shepherd write up on that. Okay. That sounds like a plan. Anything else?
So we need to figure out whether you want to have a virtual interim for hackathon prep, or you want to go to Singapore earlier, or what you want to do.
Any comments on that right now? I'm happy to take that to the list.
That's what I'm guessing, but it's what we have to do next. Part of what's coming.
Hannes, are you willing to drive that conversation on the list?
Start right.
Great, thanks.
All right, that matches the list I made during the meeting. So, is there any other business? All right, we're done. Thank you.
Thank you. Yes, can you hold up the blue sheets?
Yeah, we've done the transport related stuff already. I can also send you pointers on what that explains what we do.